Welcome to Kerbalism. I'm your host, Aubrey Goodman. In this episode, we intercept and rendezvous with an asteroid. As we expand to build stations on other planets in the system, we need to evolve our concept of manufacturing. Instead of building everything on Kerbin and launching to orbit, it makes more sense to build an orbital construction facility and use resources collected from asteroids to build new craft directly in orbit. Before we can do anything with an asteroid, we need to identify and classify nearby objects worthy of our attention. This is the first part of a sequence of tasks we must undertake in order to collect materials from an asteroid and refine them. A tiny asteroid may have only 15 tons of usable resource material. Now, while it may sound like a lot to the uninitiated, this would yield barely enough fuel to perform a few maneuvers. In order to find high-value targets, we need a solar satellite with an infrared scanner. With this equipment, we can identify and begin to evaluate possible targets. This new satellite is smaller than our solar relay. It uses less fuel to deploy, and we will eventually need more than one, so we can identify asteroids at different distances from the star. Using our infrared scanner, we begin to identify nearby asteroids. We need to find one on an intercept course with Kerbin. This makes it easier to get to the asteroid. Objects further away, or not already on an intercept course, will require more fuel and more advanced planning to capture into orbit. The asteroid itself is traveling faster than the planet, so it will not settle into orbit around the planet on its own. We must grab it and slow it down to stabilize into orbit. In this example, we've settled on a target asteroid about 50 tons in mass. Its existing intercept orbit will bring it within 39,000 kilometers of the planet. This means we need about the same delta V as a trip to Minmus. Again, we would need much more to intercept with a free asteroid on a solar orbit. Just as we saw with orbital stations, asteroid harvesters must also be assembled in orbit over several phases. For the purposes of this episode, we will build on Kerbin and send it into orbit empty. Then we send support missions to deliver fuel to the harvester in orbit. It would be prohibitively expensive to send the fully fueled harvester into orbit. All that fuel weighs a lot, requiring more powerful engines, which weigh even more. By reducing the payload mass by delivering components and parts, we can dramatically reduce the first stage fuel requirements. Once we have the harvester fueled up and ready to go, we can proceed with the rendezvous. We do this in 4 maneuvers. First, we need to align the harvester's orbital plane with the asteroid. For highly inclined orbits, this may use a lot of fuel. One of the benefits of being in low planetary orbit is easy access to refueling missions. If you use a lot of fuel, changing the inclination, you can top off the tanks before the long trip out to the rendezvous point. Second, we need a prograde burn to raise the harvester's apoapsis to match the asteroid's periapsis. In other words, we raise the highest point of the harvester orbit until it meets the lowest point of the asteroid orbit. Third, we need another prograde burn to bring the harvester periapsis up to a point where the 2 craft come within 50 kilometers of each other near the rendezvous point. This is a precise maneuver and requires a bit of finesse to pull it off. Finally, we burn in the direction of the target to close the gap, ultimately locking onto the asteroid with the grappler. After we have our asteroid locked, we point the solar panels toward the star. Then we can start drilling. Intercepting an asteroid requires a lot of delta V. there's a good chance we used up most of our fuel in the intercept process. Now it's time to get ready for our next episode, capturing the asteroid down to planetary orbit. We will need to collect ore and process it into more fuel to slow down the asteroid. Stay tuned. And thanks for watching Kerbalism.